Good afternoon, everyone. I am Hatice Hilal from Middle East Technical University, and it's a great pleasure to share my work, motion-based dynamic form generation, to contribute to the kinetic design diversity. Here is the outline of the presentation, and I am going to start with the problem and objectives. So mainly I'm interested in kinetic architecture. Kinetic solutions always exist in architecture from past to present. In this way, the buildings gain the ability to adapt to the changing conditions. But it is predicted that the use of these systems will increase even more after the pandemic, because we saw that the changes can occur suddenly and in a size that can affect large masses of people. So mainly, the problem is that static architectural spaces cannot adapt to the rapid changes, the changes affected by technological improvements or the social crisis, the changing demands of the users, etc. Designing transformable buildings is an effective solution to this. However, this is the main part. Sufficient design diversity may not be provided with the existing kinetic systems in architecture because there will be more demands to fulfill. So my goals are to explore the potential of motion tracking technology, which I believe that we can use it to increase the kinetic diversity and to generate motion-based dynamic forms. Let me walk you through the literature review that I conducted about motion capture technology. So capturing and visualizing motion started to be done in anatomical studies, and these studies made an impact on photography. The series of pictures on the left side belongs to Muybridge, who is the pioneer of the field. It's called time-lapse photographs. We can only perceive the movement of a horse temporarily, and there is no relation with the space, as it is one-by-one pictures. On the other hand, on the pictures of Murray on the right-hand side, now we can read the movement on a single photo, on a single image. There is continuity, and we can perceive the relation with the space. But the problem is that there are overlapping poses causing confusion of the content. We cannot clearly see the movement of the horse, of that horse. So Murray solved this confusion with his motion capture suite on the left-hand side. It's a black outfit, and there are metal sticks on the limbs of the subject. So with this technique, he was able to capture only the essence of the motion, independent from the subject. This is the basis of motion capture technology. Nearly 100 years later, in the study of Johansen, instead of metal sticks on the limbs of the subject, now we see reflective markers on the joints of the body. So what we understand from this study is that whatever the movement type is, running, walking, jumping, we can perceive it from only limited number of joints. So the important thing is deciding on where to put the markers. It's critical. And this technique was improved, and in today's it is called optical marker-based motion capture system. Now on, I will talk about turning digital point data obtained from any motion into a form. Here you see the generation process of MoSculpt. It's motion sculpture. It's a research of MIT. It's a way to analyze the traces of an athlete's movement so that other athletes can improve themselves by looking at it, by observing the sculpture. And it's quite interesting to see the form of running, for me at least. I'm sorry. So how we can use motion capture in architecture? In the research of Hirschberg, the main focus was on motion, actually form finding through movement. So there was a workshop and students came up with different motion scenarios. And these motions were captured and transferred into digital programs. And then wooden sculptures were produced at the end with the help of laser cut machine. So in usual design methods, it would be difficult to think up with such kinds of forms. But thanks to motion capture technology, it's easier. And also, it provides unlimited design potential, so which excites me a lot, actually. So I got inspired by all of these studies and many more, and I wanted to use motion capture technology in kinetic architecture. Let me present you the methodology of my research. I used optical marker-based human motion data from an online database of Carnegie Mellon University's research lab. So what is optical marker-based motion? Basically, there is a special cloth similar to Marey's motion capture suite that I showed you. And there are markers on the joints of the body. And these markers can be detected by cameras. So what I did is I visualized the movement paths of the markers, which I located on the head, hands, and feet, and I created surfaces out of them. Next, I focused on the isocurve distributions on those surfaces, which is related with the speed of the motion. And then I decided on where a moving mechanism can be added to on the form to obtain a kinetic form. And lastly, I made some classifications and I analyzed the speed of the motion. The programs that I used in this research were Maya, Rhinoceros, and the scripting language Python. Now I'm going to show you the data collected. This is the first motion type that I worked on the motion sculpture process. It's called forward jumps. Here you see the screenshots taken from the video 0101. It's the first motion type available in the utilized database. And these are the visualized traces of the selected parts of the body. I converted these traces into curves with the help of Python coding within Maya. And here you see the mesh created from the curves obtained from the traces. You see it from the side view. And then I wanted to get the volumetric center of the form in order to use it as a reference line for the design of the architectural spaces. And again, I used Python coding within Maya. Later on, I exported the surface and the reference line into Rhino. And then I decided on where can be the joints of the form, and I created smoother surfaces on those areas. Later on, I splitted the form, and then I placed horizontal and vertical planes with reference to the center line of the form for spatial use. And this is the first idea popped up in my mind. It's a quick design proposal. Here you see the mock-up model of forward jumps, on which I experimented on how it can move. Afterwards, I collected some more motion types. In total, in here, there are 15 movement types, sorted by movement duration. The first one is 25 split seconds, and the last one, as I remember, it was around 10 seconds. I can see, yeah, around 10 seconds. You see the traces and the surfaces from the top, side, and front views. So when the motion is fast, like running, there are less isocurves created on the surface. But if the motion is slow or getting slower, then there are more isocurves on the surface. So what I thought is, if we combine different types of motions, we can distinguish where can be the joint of the form. So from where we can divide the form. For example, in here you see the surfaces which have more clear joint positions. When we look at run, stop, run, we can say that in here there are more closely spaced isocurves, so we can split the form from here. And benefiting human motions created very interesting patterns. They are all different from each other because the initial movement types were different and the scenarios were different. And this excites me a lot again. Now I'm going to present you the speed analysis. These are the features of the collected motions: movement type, number of frame, duration, and number of joints in the form. In other words, how many pieces the form is splitted to. I wanted to make a classification of these movement types according to their speed. So the aim of the study at this stage was to understand how the speed of motion affects the number of joints of the form. I wanted to make a generalization on it. So I resized the data until all the movement types have equal movement duration. And in Maya, if the number of frames is increasing, then the speed is decreasing. So here is the plot showing that. I divided it into high speed, medium speed, and low speed. So accordingly, these two movement types are considered as fast. These have medium speed, and these are slow types of motions. And this is the plot showing number of frame versus number of joints. I can say that in these kinds of research, it's better to choose fast or slow types of motion because they gave closer results within themselves. I'm concluding my talk with the limitation of visualizing motion as a moving form. So I gave the priority to the non-overlapping motion types. The trajectories of the markers should not intersect with each other because if they intersect, as you see in here, it complicates the use of space. So finding appropriate movement types was a big challenge in this research. And also I tried to make some classifications in order to facilitate the movement selection. I did not use all of the markers, but I only selected the ones located on head, hands, and feet. So some other methods can be developed in here to facilitate the movement selection and also utilize from the overlapped motions. In conclusion, using motion capture technology in architecture can bring new perspectives and also particularly turning motion into a moving form can be a solution to increase the diversity of kinetic designs. So thank you very much for your attention. This is the end of my presentation.